I think it took guts to decide to have this as a class project. There's going to be a big desire to look at things like the industrialization of space, the impact of private adventure travel, tourism, and what an impact it has on the entire world. That will always gain a lot of enthusiasm. And I think as far as the moon is concerned, until it's quite necessary, we can take people to the moon and they can stay for a good while, subject to radiation and other conditions, and they can come back relatively easily at not much cost. And that is not really the situation at Mars. And I think the impact of resources at the moon that it has on bringing partners together and sharing the cost and allowing the technical aspects of leadership to diplomatically avoid confrontation and external confrontation and space duplication. It's so much better intellectually to look over the different ways of doing something, deciding which one is best, and then everybody does the best one, or something to that. But to spend a lot of investment on two things that are conflicting at that level is quite wasteful. It's difficult to imagine the financial return on investors in the large cost of even scientific efforts, engineering efforts, but human expansion efforts, unless there is a return. Now, at the moon, it's resource and stepping stone. A whole idea of building manufacturing with those resources and supporting them with the propellants to get there, or a different propulsion system that is much more efficient than chemical. But it still is sort of close. I think most people look at the hazards of catastrophe and maybe even get somehow into routine or boredom. But I think there are things even more important than that, and it's a major mental health switch between being on the positive side, and this is especially true, not of a 1 year in space, because the person knows that they're coming back at the end of that time. But when they make a commitment without thoroughly thinking that through, they got to be mature enough, and do they really understand? And that's why I don't think someone can make that until they're mature enough, and I'm not sure that 20 or 25 years, I'm kind of looking at 30. Now, do we want people to land on Mars that are 45 or older? We're not going to get that much use out of them. So there's a time period between commitment and when you use them. You have to be pretty unhappy with retirement here on Earth. But there is an option that hasn't really been considered that much. And I think it's coming up, of course. we send people suborbital. They don't quite get into orbit. Then we put people into orbit, and the next step is we can go around the moon, and then we can go into orbit. The big step is going down on the surface, and there has to be a pretty good reason to make that investment of down and back. Now, I think as far as sending people around Mars, not many people have been given it that much thought, and there is a flyby. Nobody else has pursued the cycler, which flies by, but under its current limited, you're going to leave Earth, you're going to get there, and then the next trip coming back is not going to be for almost 2 years,
Right.
and then you come back. But I can certainly imagine even a 2.5, 3 year bucket list trip on a wealthy person who might find that the transfer is not too much of a burden, but it's staying on when nobody else wants to stay all of that time. And we have to have all the radiation protection, but he's already lived to a pretty long life anyway. But I'm serious. I can see this as coming to be one of these. Now, can we afford to do that for a person? I don't know. I really couldn't. But as soon as I could make it an even shorter trip than that, like, is there a flyby of Mars? Well, about 3-4 years ago, there was Inspiration Mars, and the only trajectories they could find would occur every 15 years, and it was kind of like a 500-day trip, and to initiate something like that just didn't look like it could be inspiring to then let us go further. So its inspiration value was pretty infrequent and costly. But if you can reduce that to 6 months going and maybe 10 months or so coming back, where it's just a little more than a year, why, I think you can market something like that down the road, not to start out with. But I think we always should look at, if you start something out, what are the end result? And to look at one base where everybody's there is quite unrealistic. You're going to run out of resources around there, but you're going to want to look at many different parts. The travel industry is pretty big here on Earth, but it's got to be not Conestoga wagons starting out. Well, I think you've cracked the door open that needed to be done, and what it will generate is a lot of very good thinking in the structure of surface facilities, and whether you're going to bury them or not, and how soon you can 3D print a house out of local stuff. But there is one thing. Right now we've got 2 moons, one around Jupiter and one around Saturn, that look promising for satisfying life. And yeah, it's worth getting that answer, and it may be a better answer or a more probable than finding evidence of life, past life. on Mars. I mean, there may be life existing in these oceans below the ice. And it's a great realization in history, but should it come at the cost of doing that before we make the most of what's in front of us? And that brings to mind something that the minerals here on Earth that we're running out of, not that many came up from the molten core. Most of the rare ones were the result of impact, and the same impact that produced the minerals that we're running out of impacted the moon. Now, is it better to go to the impact source, or is it better to go to a place where it's there? And I've always been concerned that it's so much easier to find the remnants of not just ice, not just water, because that stuff disappears. But a mineral is pretty hard to evaporate that and have it disappear. And the people looking for the resources of an asteroid, I would certainly think that a lot more should be expended on the impact of those asteroids on the moon and the resources there. But I haven't seen that evidenced. There is a nuclear reaction that is reachable now and hasn't been exploited. It's called, well, in California, to avoid the nasty word of nuclear, it's called thorium power. It's radioactive. I mean, it's marginally, but there's a lot of it, a lot of thorium on the moon, a lot of it on Mars. I'm not sure that the buildup is there. I know the people who are interested in propulsion in space are interested in its compactness. It does not contribute to weaponization, and there are a lot of people that are interested in that, and it burns, consumes radioactive waste from light water reactors. So, but it is something that may find a place, and there's another unresolved, and that is beaming energy, high-powered laser of power, more efficient from the sun around the moon than a nuclear reactor on the moon. Right now, I'm looking at NASA's study of reactors on Mars, their compactness, their levels, and if they're thinking of that, they must somehow have figured out how they're going to get them there. And if they can get them to Mars, we can get them to the moon a lot faster. So there's a lot of short-term, and I've been a supporter of power beam from space, but the fact that it really has had highly credible people concerned as to its effectiveness, it's the transmission. It either is what they claim or it's not, and it'd be nice to have, at the moon anyway, an alternative to the nuclear regulator, nuclear reactor. You could tolerate putting it on the surface, but I think putting it at a refueling depot, the whole idea of refueling components out there, if they're not going to land, and if they're going to land, you refuel them on the surface, but to send something from the Earth out there to refuel, if you read the fine print, after they're refueled and you get a crew in them, I think they depart for Mars out of a high ellipse. Around what? Around the Earth. Well, if they swing by the Earth, why didn't you start from orbit around the Earth and never use Earth propellant to take them out there, but use lunar propellant for all of the added velocity? I mean, there are flaws in every argument, but to use Earth fuel for everything going somewhere right now is kind of unthinkable, but we're going to use it because we don't have lunar fuel yet, and it's so important to refuel that we'll refuel it a little uneconomically at first because it's a great payload for a booster that isn't useful doing other things.